Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Joel, Seth's brother. We're here to hopefully show you how to approach SAT math questions and also how to approach studying for the Math SAT. Today we are for the while. We're going to be dealing with the Khan Academy questions, which the SAT College Board gives you access for free. The SAT post 2016 test is made up of 40 topics. They give you 20 questions per topic, and we are going through these topics. We are really at question 11 of the 20. You get 5 questions per level. We are at level 3. This is not the easiest types of questions, so today we are only at question 11 of 20. Okay, here we go. So why don't you try it? Do it. Pause. Come back, and here we go. So it's called the topic is linear and quadratic systems. On the SAT, you're not going to be told what the topic is. But anyway, okay. If A and B is a solution to the above system of equations, to the equation shown above, and B is less than 0. Oh, Y is less than 0. The answer has to be less than 0. What is the value of A? You could always think graphically or algebraically. You may be able to do this graphically. It's possible, but maybe it's. But
Well, might it be done graphically when you have a graphing calculator?
Yes, actually, a graphing calculator is allowed. Oh,
Yeah.
that probably would be a very good way to do it. We don't have. We should really set ourselves up with an emulator, a graphing calculator emulator. Wouldn't that be cool if we had that? And that we can do it on a graphing calculator, like show ahead of people. Show ahead of people. So I guess people are just gonna have to do that on their own. How to do
Well,
it?
you could use GeoGebra.
Not on the SAT. You can't.
No, no, no.
No,
Okay,
no,
no,
no, no,
no.
no. So today, then, so if you
Well,
were going to do it graphically, you would graph both of these equations. You may have to write this as x squared, or I hope I don't make a mistake, minus
mm,
6x plus 18. You would graph that, and you would graph negative 7x plus 12. And where they intersect below the y-axis, right? Because b has to be less than 0. Where they intersect below the y-axis is the answer. Now, what type of graph is this? This is a plus 12. Oh my God, minus 7. You got a very steep slope. And this is a
well,
downward
uh,
parabola. This is a downward parabola that probably has roots. Who
uh,
knows? And it goes like this. Ooh. Oh, then maybe it
wait
has
a minute.
something like that.
The line is negative slope.
Oh, man. Oh, I always do that. Oh,
Yeah.
God. Yeah, you're right.
And
It's
the
a negative
parabola
slope.
is concave downward.
Right, exactly. Oh, yeah.
Yeah.
So eventually there will be an answer. I don't know what this
Like
looks
that.
like. I don't know
Oh,
what
yeah.
this looks like, but I'm just drawing a random downward parabola.
Ah, I see. So,
So eventually there will be an answer. Now, because you need to know exactly the number, we can't do it without a calculator. We wave our hands, but we're never going to be able to graph it
they
exactly.
could do it on graph paper.
We could, but okay. So I guess
Yeah.
we have to
So
start doing
I
it
don't
out the
think,
way.
would it be feasible to do it by hand graphically?
I don't think so. It doesn't look like it would.
No.
So we might as well just do it algebraically then.
Yeah.
So we just what is the value of a? You're looking for the x value, so then you have to
Mm.
set the two y's together, and you're
No.
left with a quadratic. Oops. Ooh, remember 2 days ago, Seth and I blew a really go back to that video if you want to see us crash a few days ago. So then you have to solve for x. So it's a quadratic. So what does that mean in a quadratic? Be careful. There are negative signs in a quadratic and distributing, which means the chances of making a mistake go up astronomically. So you've got to be really careful. So let's see how many mistakes I'm going to make. Seth, you can watch me. So I double check when I do this thing. I double check because I know that it's easy to make mistakes. Okay, looks good. Oh, you have a negative x squared. Come on, come on. Well, I guess
Put it on the right.
yeah. So we're gonna subtract an 18, and we're going to add a 6x, and we know what we're going to do with the x squared. So x squared, now we've got a plus 6x here and a minus 12 here. Notice I'm being careful because it's so easy to make a mistake. Isn't that a minus x? I think so.
Wow.
And isn't this a minus 6? Double check the work. I know I'm going slow. Add 6 minus, right? Add minus 18. Yeah, okay, fine. Now, so this is factorable. X and x. 6. Isn't this a
3 and 2?
3 and a 2, right? And this is a negative sign, which means they're opposite. So the negative sign is the bigger one. So then you go like this. So x is negative 2, and x is 3. Oh boy. Now we have to see which one gives you a negative y. Looks like the 3, doesn't it? Yeah, it looks like the 3. The 3, when you put the 3 in here, you get negative 21, which overpowers the 12, so it would have to be 3. Right? You know, a problem like this, if you're doing it algebraically, that probably is a really cool short way to do it. But maybe not. I mean, and maybe by the time you figure out the cool short way of doing this algebraically, you might as well just do it the long way, but it is a long problem. This is one of these problems I feel like you have to do the other questions as fast as possible to save time for this one.
Yeah.
What do you think?
Well, graphing it somewhat accurately led you to guess that the x equals 3 should be checked first.
No, but Seth, I didn't know how to graph this thing.
I told you how. I told you the line. You said the line is very slopey. It has a high magnitude of slope, but you drew it with a positive slope. I corrected you.
That's right.
So you drew it with a negative slope.
That's right.
And then I said the parabola points downward.
Of course, but it could.
And then you said, look for the root whose y coordinate is negative.
That's right.
And so you drew that big purple dot with a little loop on it, but where the y coordinate is negative, and since the parabola opens up downward, and the line slopes downward for larger and larger x, that leads you to think that that at least one of the negative roots, at least one of the roots where y is negative, is for larger x.
Right.
Right. And you picked so you picked the larger x, and then you observed that the equation, the linear equation for y, has a right-hand side where the coefficient of x is negative.
Right. Yeah.
So to make that negative coefficient give you a negative number, you need to put in a positive x. And the positive x has to be big enough to overpower the 12.
Right.
When it's multiplied by 7.
Right. Yeah, so basically, so one type of method, reinforces the view of the other method, which is really good. And if you have time when you're doing real math, not SAT math, to analyze and understand this stuff, in fact, it's good to do that when you're practicing so that your brain is ready to be able to do this stuff almost subconsciously when you're actually taking the SAT.
Yeah.
Notice that, but I see a thing is I could have drawn the parabola this way, right? But if I drew the parabola this way, there would have been 2 solutions. Right? We don't really know what this negative parabola is. We could have gotten the vertex and been better with it.
Yeah.
But this would have given you 2 answers, right? Which probably wouldn't have been consistent with the answer.
Yeah.
But let's see what else. We could have drawn it. We could be creative. Oh, I guess if we drew the negative parabola this way, that does seem to be like the default reasonable parabola, right? A plain vanilla ice cream parabola. As opposed to some weirdo parabola, which would be over here, relative to the line. That would be strange. right?
Mm,
But anyway, so I just drew a plain vanilla parabola. Um, okay, so I
mm,
guess there's really no way. I don't know. There probably is a fast way, but the idea here is if you have to do these types of calculations with quadratics, do them carefully. To maybe because I personally, Seth sort of also we got burned 2 days ago. If we go back to the video, we crashed. We multiple mistakes on quadratics, so maybe now I'm a little more
mm.
careful, which is good when you're doing work. You may find that you make some mistakes on some problems more than others. Those are the problems you want to be more careful on. Anything else on this? Should we do throwback? We're doing Throwback Thursday today.
Yeah.
Okay. Okay. Uh, let's see. How does this work? Do we put the answer in, and then they tell us how to do it? Let's see. 3. Okay. Check answer. Let's see. We have to answer it because we have to go to the next question eventually. Oh, look at us. We're right. Okay. How do
No,
they do?
our answers agree with their answers.
Okay, you're right. Technically, you're right. Okay, so they're doing it the traditional way. They're doing it the traditional way. They're doing it the
Yeah.
traditional way. Yeah, yeah, yeah. Now, wait. We need to find the x value. We need to find the y values to each of these solutions.
Mm,
Wow, look at that. They waste their time on the. I guess. But wow, that's pretty interesting, right? That once they found the y negative 9, they still went for the positive. They still
mm,
went for the second y.
mm,
Anyway, okay. So, whatever. So, today's Throwback Thursday, which means we go back
mm,
to a
mm,
test that
mm,
predates 2016 when the tests were a little different. They had a different feel to them. They were more reasoning tests. You never really knew what was going to be on those tests as opposed to now where you have the 40 questions, the 40 topics. So, we picked a question from a official SAT book. Look at this thing, vintage. Wow, 20 years ago. Here we go. This book is so interesting. They give you the answers, but they don't give you the explanations on how they get the answers. So it's pretty interesting. We only have the answers to these, but no explanations.
mm.
Okay, so here we go. The Zeitboard's ready. Oops. What's that about? Come on. Oh, wow, it appeared. All right, here we go. And I have the answer here. I took a picture of the answer. It's over here, so we'll be able to check ourselves. So we'll see how that works. Okay. Okay, so this question, as you can see, has a very
Um,
different feel than other questions we've dealt with. And here we go. This expression, this is how much more than X.
what?
Is how much more. I know. Exactly. Like, what? What type of question is this?
Well,
This
I
expression
think
is how much more
the
than X.
how much more than X. So I don't know. A little bird tells me that is you take that expression and subtract X from it.
You mean you
Because
do?
what I'm thinking is what I'm thinking is that that expression is up here,
Okay.
and X. You want to know how much more is it than X?
Okay.
So I'm thinking that X, it is more than X. How much more? I think is X is less than it, and how much does X go up in order to get to it? So that's why I subtract. And then when the expression above really is more than X's selection below, that subtraction, the big number minus the small number is going to be positive.
Okay.
So that tells me that that what you wrote down is the accurate expression in algebra for what the English question asked for.
All right. And this is, I can see already, this is going to work because the X's are going to cancel. because you got a 3/4 x plus a quarter x
Oh,
minus a 1x, which means we're not gonna have x in the equation. We're not gonna have x in
well,
this expression anymore.
it would make sense even if how much more it makes sense to think about this even when how much more depends on x is a non-constant function of x,
Oh, right. Okay. Okay. Okay.
right?
Okay. Okay. Now,
And
set.
in that case, it might be that how much more it is in x might be a negative number.
Yeah. 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 You're
And when
right. Whatever it
something
is,
is
it is. Yeah.
more, when A is more than B by a negative number, then A is actually less than B.
Got it. Right.
And indeed, if I would say from a mathematician's point of view, you finished writing the answer.
Okay. Okay.
I would, as if this were a college math class, I would be forced. I feel myself logically obligated to accept what you wrote as a correct answer.
Okay. You mean okay.
But if I were a college professor, I would write simplify as much as possible.
Okay. So that's okay.
Let's
So
simplify it
three
and see if
quarters
it's to be
x
simplified.
minus a quarter plus x over 4 plus 6 over 4 minus x is the answer.
Yeah.
So these cancel out. Luckily, that's
No,
nice.
they don't.
Yes, they do.
They
Three
they don't
quarters
cancel
plus
out. They add up to one.
they add up to 1. So you've got
You add up
x.
to one x.
You've got x minus x. Now we have this 1 minus a quarter plus 6/4 is the answer. So the x's cancel. So we have 6/4 minus 1/4. So we have 5/4. So the answer would be 5/4. Right?
Right.
Yeah. Yeah. So Seth used this. Another way to view this when you have things like this that sound confusing. One way one day I like to do is take this and just make it a 23 or something.
Mm.
Okay, and then you say 23 is how much more than x. So if you want to use that, that makes more sense. If you want to know how much more 23 is above x, then it would make sense to do what Seth said, which would be 23 minus x. That would answer how much more is 23. How much the expression 23 is how much more than x. You would write it this way. This is a very smart way of doing it.
Yeah.
I don't
Now
know.
I remember sometime in school. I remember sometime in school, I think multiple times, both in math classes and science classes, they spoke about, they presented problems about how much more one thing is than another thing. And then I remembered thinking to myself that that there is a rule that I think I actually thought of the statement of the rule, and I thought to myself that that these words confuse me, and so I ought to. So I thought to myself that I will memorize the rule.
Wow.
And the rule is that when you are comparing a thing to what you're comparing it to. So the thing that you are comparing, the rule is it depends on whether you're comparing by ratio or by difference.
That's right. I was gonna mention, yeah.
And when it's by difference, you write a difference where the thing you are comparing is given with a positive term, and that the thing you are comparing it to is subtracted from it.
Right. Right.
And when you're comparing it by ratio, the thing that you are comparing always goes in the numerator,
Right.
and you divide it by the thing you are comparing it to.
Right. Yeah.
And so I'm thinking in a little bit beyond SAT math, they teach about vectors.
Don't go there.
They teach about arrows,
Yeah.
like bows and arrows. You're shooting an arrow from here to there. How many miles does the arrow go? You take the place of there, called KM there, and you subtract. You always take M there, take M there, where you are, minus M here.
Right. M star.
When you find out how to get to there from here, you take the 2 with a plus sign and the from with a minus sign.
Right. The other way to view it, which is helpful, is you put the 23 in, but even this is confusing. The expression 23 is how much more than x. Maybe to get a little more insight into this thing, you can do something you could try doing this problem. 23 is how much more than 21. Okay, so what you do is you replace these crazy things with x's in them to real numbers, like actual numbers. And now most people taking the SAT can do this. 23 is how much more than 21? 2, right? 2. So how did you get that? You did 23 minus 21. This is a model question that's very, very doable because it has English and almost everybody can do this. Then you translate what you did here up to this problem, and then you get what Seth said, but Seth has some experience. Seth's like into these different things. So Seth immediately knew what to write. But I don't know if that may not come to some people. Certainly, actually, I don't know if it would have come to me as fast as it came to Seth.
Well, again, my memory is that I don't have any memory of a teacher or a professor explicitly stating this rule.
Right. Yeah. Okay.
What I remember is example problems, in which they apply the rule.
Yeah. Well, I remember.
And then student exercises that asked me as a student to apply the rule.
Yeah. Well, I remember always being intimidated and scared of subtraction because if you get the order wrong, you get the question wrong. So I always had a little fear whenever I did these questions to say, there's a 50-50 chance I'm going to get it right. And therefore, I sort of came up with this way of figuring out how to do it with a question where I certainly know the answer. I don't have to think theoretically. I can do this. 23 is how much more than 21 is 23 minus 21. Then you apply that rule. But I do remember these questions as being not that easy. So I guess that's it. Oh, yeah, let's look at the answer. So we say 5/4. Okay. So
now let's say let's not say the answer. Let's say
oh, look at that. Notice this is so interesting, right? They give you the answer. You can see it's 5/4, right? Or 1.25. But they don't give you any explanation. The book has no explanation for for anything, but they do give you 10 tests, so that's nice. It's a thick book. They give you 10 tests. Tests were really large back then, very long tests. Actually, they still are now. But anyway, so we don't know how they would have done it.
Yeah.
So they probably would have done it similarly. So, okay, so I guess that completes Throwback Thursday. Oh, maybe we didn't really explain Throwback Thursday. Throwback Thursday is when we go back to a test that predates the 2016 test to get a sense as to what the tests were like before 2016 when they changed the nature of the test. So this is, I'll give you a flavor for what the tests used to feel like. So I guess that's it for today, right?
Right.
We did polynomials. We didn't make big mistakes like we did earlier in the week. Always remember your mistakes and learn from them. You learn more math when you make mistakes. And we did Throwback Thursday. Wow, cool. Okay, have a great day, everyone.
Okay.
Bye.